Hi guys, I would like to demonstrate this problem using this video. So the purpose is to find the derivative of this guy. Well, one thing that you don't want to do, try not to do that when you see that you have a function that's product and several power with different types of function, and at the same time it is also a quotient. So if you use the previous rules that we learned, you might attempt it to use the quotient rule, right? So you're going to do the low square on the bottom, and the top is low d high. And now think about this d high. D high is a product of two different composite function, minus high d low. And of course, you can imagine that it's pretty complicated, this problem. And then, by the way, when I pick this problem, I did not pick something that's really complicated. Just imagine, like in class, we mentioned that what if you have another function here and another function here, right? So it will be a pretty not something fun for you to do. So therefore, we should use some other techniques, which is called implicit differentiation. And then this is the first formula that we need to use when we use this technique. So natural log of x times y, you can write this as sum of two natural log. And when you have natural log of x over y, and becomes the difference of two natural logs, right? So we are going to use that. So the first step is you're going to apply natural log to both sides. So natural log of this guy, x cubed minus 1 raised to power 4 times square root of 3x minus 1 divided by x squared plus 4. And now apply the rules that we just introduced, these two rules. So the first one, you're going to have x cubed minus 1 raised to power 4 plus natural log of square root of 3x minus 1 minus because x squared plus 4 is in the denominator. So x squared plus 4. Okay, so this is the we do a little simplification. We should continue to simplify. We want to move this power 4 to the front of the natural log, so that this is a simpler function. Not like now it's ln of a u, and u is another composite function, right? So you don't want to do that. You want to move this 4 to the front, so that 4 times ln of just a simple, pretty nice function. So similarly, you want to rewrite this as 3x minus 1 raised to half. So I'm going to do that right now. So actually I want to rewrite this square root as power 1/2. Okay, so the purpose is to move the power to the front of the natural log. Okay, so 3x minus 1 minus natural log x squared plus 4. So the next step is to differentiate both sides with respect to x. So this is a composite function ln f. We discussed how to find the derivative of natural log of a function in class. So we actually observe the pattern, right? So it is f prime over f equals, okay, for the right hand side, when you find the derivative, it's going to be 4 times. So for the first one, your u is, this is your inner function. This is your inner function. So it will be derivative of inner, which is 3x squared over this guy. And it's the same idea, right? That's the same idea. F prime over f. That's the formula we derived in class. So plus 1/2. Similarly, this will be 3 over 3x minus 1. Where's the 3 from? 3 is the derivative of 3x minus 1, and 3 minus 1 goes to the bottom because this is the derivative of natural log. So minus 2x over x squared plus 4. Again, what we are doing here is basically the derivative of inner over the inner, just coming right from here. Now, so this is actually this should be my second step. The first step, we apply natural log and simplify. The second step, we differentiate both sides with respect to x. The third step, basically you just multiply both sides by f, right? So that the left side you're left with just f prime equals f times the whole. So I'm gonna use my little tool. Okay, this is something I want to copy. So f times the whole thing, basically. Okay, right? Missing a 4 right here. Did not copy the 4. So just multiply f to the other side. So f times the whole thing. And of course, at the end, we need to substitute f as your final result. So what is your f? X cubed minus 1 raised to power 4 times square root of 3x minus 1 divided by x squared plus 4 times the whole thing, right? Times the whole thing. Okay, so I think we just need to copy that down, and hopefully this makes sense to you. So I'm gonna copy this down. Okay, basically times this guy, right? By the way, this method is called the logarithmic differentiation because we apply the log to both sides, and we actually differentiate the log functions. We differentiate a lot of log functions, right? And it works because of these two properties about the log. It can convert products into sum, and it converts a quotient into a very nice just difference, right?